Hey, we got one last SPI presentation for you. Here is Benji with the LiDAR mapping robot.
My name's Benji. Let me just start. My slide format didn't copy over, so it's kind of weird. So I apologize for that. But yeah, my name's Benji. I'm a fourth year at IEEE. I saw a YouTube video over the summer, and I was like, this looks pretty cool. But all jokes aside, I did about a couple months of research in under mechanical engineering research lab for a couple months, and they did LiDAR mapping. So this inspired me to kind of do my own. So just to kind of give some background, what is LiDAR? I don't know if they went over it, but I'll go over it in case they didn't. So LiDAR, I have my speaker notes, I'm just gonna read off of this, but LiDAR stands for light detection and ranging, and it's a remote sensing technology that uses laser light to measure distances. It works by emitting light, laser beams towards the target and then measuring the time it takes for the reflected light to return to the sensor. So this data creates precise three-dimensional or two-dimensional information about the shape of the Earth or surface characteristics of anything in general, objects, anything that you want as your target. So LiDAR is often superior in cameras and scenarios that require low light or high precision. Usually, normal stereo cameras require light in order to capture an image's information. So LiDAR really works well in really low light situations. So that's why you see these bright colors in very dark situations. So yeah, pretty cool. You can get pretty great, realizations of environments. And the one thing that I use, which is an algorithm called SLAM, to help create my maps for LiDAR point clouds. So SLAM just stands for simultaneous localization and mapping. It's a technique usually used in robotics and autonomy to build a map of an unknown environment. Yeah, so that's just main background. Just the equipment. Just to start off, LiDARs are kind of expensive. This one is already $100 and it only does 2D up to 12 meters. So normal research labs is $600 for a basic 3D camera. So my goals weren't that hard because I just didn't have the money. And then I used the Raspberry Pi for the main brain and just some basic cables to connect everything. So software, I used ROS. ROS is a very well-known robotics operating system package. So it's kind of acts more of a middleware to kind of give your sources packages to kind of do different types of things. So it's very great because it just has a lot of libraries that you can use to really integrate, and there's a lot of things that you can do. I had to use an Ubuntu because ROS doesn't work on Mac OS or Windows, so I had to do an Ubuntu install. And then I used Hector SLAM. So Hector SLAM, there's a bunch of variations of SLAM, each different types of environments that you have. So Hector SLAM is usually good for flat terrains and very low light. So we're not getting a lot of changing environments, it's just very relatively all the same. So yeah, I'll show my demo. I did this at 5 a.m. in the IEEE lab. So you guys know where that hallway is, where the IEEE lab is. So it's the IEEE lab, you have whatever's behind it, and then whatever's in front of it. So I'm not very descriptive, but if you guys know what I'm talking about, yeah, it's a very nice hallway. So I can't really point that well, but that part at the top where you see those two lines, that's the IEEE door open. You can kind of see how these rays go into the lab, but since there's only a very limited range, it just kind of goes off into the distance without really making a defined shape. So I'll just play the video. Yeah, so that little distance is me moving around. The red is what it's currently picking up, and the black is what it defines. So yeah, there's the door that I was getting, the pillars, and the other pillar. So you can kind of see it right there. It's kind of outlined in a sense. It's a very low demonstration. Once again, I don't have that much money to make fancy graphics. But so yeah, that's basically it. I had to write the Hector SLAM package myself, which actually took most of the project. It's in C++ and C, which is annoying to do. So you have to kind of do object detection for what you think is a door or a wall and what isn't. So if you kind of see that red line where the green lines are, that's my head recording. And it's only red because it knows it's not a stable object. It knows it's a moving object. It's a head, my head. So yeah. Sorry that it's not I could do a live demo, but I have to set everything up. I could probably do that for tabling, but yeah. Yeah, so the main takeaways, it was a pretty fun project. This actually tracks in real time, so if I were to set it up, it can probably move around. I did try to use the EC3 card, but it was really low. So the EC3 card is this tall. So LiDAR just adds like an extra inch. So I wasn't really getting that really good map, so I just made like cardboard and just put the LiDAR on top and just kind of walked around. So it's pretty fun. And once again, 3D maps are really hard without money because they're expensive. And yeah, it's just some future improvement. Since I am using a Raspberry Pi, it's slow. It's really slow. So one thing to overcome that is probably use some networks. So if I have my own like Wi-Fi source or network or IP address, I can send information over that, download that to a more powerful computer, and I can render things a lot faster, especially if I want to do 3D. Find better supported cameras. I bought a camera for like 20 bucks to try to see if it could do 3D. Didn't work. And then probably better moving system. Sanjit suggested an RC car, and I was like, that probably could work. Just add, I don't know, big wheels and LiDAR right on top. And yeah.